a sub 3 was 1, so then I've got a cosh of beta. What's beta equal to?
N, which is just 3.
Yeah, beta is n pi over a. So
A is
this,
already pi.
for n equal to 3, for a equal to pi, beta is just what? 3. Okay, so we got cosh of 3y. And then, let's see here. And then plus the cof.
3b.
What's that?
3b.
It's 3b? Okay. Cof of 3b, sinh of what?
3y.
Beta y, which was 3y, right? Oh, this is also times the cosine of 3x, right? That cosine 3x multiplies everything. I mean, the way he factors out the cof basically in his solution, from my perspective, it is nice. It's a better way to write the solution, you know? So if I can read correctly, this is allegedly equal to minus 7 times y minus b, plus, if I use his way of doing things, 1 over the sinh. So what did you say n pi b over a was? A is
3b.
3b, yeah, it's sinh of 3b, and then times the sinh of 3 times y minus b, right? Times the cosine of 3x. I mean, clearly his solution is, you know, it's prettier than mine. So sad. Are those the same solution? Let's see, let's try plugging stuff in. What happens if we plug in y equals to b? Right? Put y equals to b, that's 0. Put y equals to b, we get what? We get, make sure I'm not talking off screen here. So we put y equals to b, that's 0. This is cosh 3b, cosine 3x, and then this becomes cof times, that also becomes cosh 3b, cosine 3x. So I must be missing a sign,
Negative sign.
a negative sign somewhere. Huh. I mean, this quite clearly works when y equals b, right? 0, 0.
Holding 0.
For some reason there should be a minus here. It probably goes back to my algebra on the tan. Yeah, look. Oh,
that
good
is a
grief.
minus. Yeah.
Yeah, that's back here. Golly. Details. Apparently they matter. I should probably have panned over there when I was doing that, So I was just pointing out that the sign error we made was here. We forgot that when we solve there should be a minus here, which puts a minus here, which ultimately puts a minus down here, which ultimately puts a minus other places.
Stop writing math notes in pen.
Mostly here
Here.
and here, which is necessary actually now that I think about the stupid adding angles formula for the cinch here. If I'd been more careful, we would have seen that. Sorry about that, guys. And of course the answers in the back of the book in Nagel, Saff, and Snyder always involve these kinds of simplifications. So like, you get through one of these like 2-page monstrosities, right? You get your answer and you look at the back of the book and you're like, hyperbolic cotangent? Of what? How did they get that? Well, it's about a third of a page of hyperbolic identity manipulation to get you there.
They gotta be using software if they get that kind of answer.
Nah.
It's gotta be kind of hard to see all the
No,
identities all the time.
they just know these things. No. These things, once you do this stuff, you know this stuff. It's not, you don't need Mathematica for the week. Sorry. Sorry.
It's alright, I don't use it.
You know what I mean? No, but joking aside, I do think that Wolfram Alpha is not always so helpful in these sorts of things because it knows too much. It'll start telling you things about polylogarithms and hypergeometric functions and this and that and the other.
The call?
Nah, it's not the call. It is merely the alarm. But I'm driving my own car today, so I should be okay. Except for the whole police stopping me because my tag expired part of today. But anyway, that aside, kind of a drag. But apparently, if you don't renew the registration on your car, they'll eventually they get you for that eventually.
I'm also.
I just didn't realize.
It happens to a lot of people.
Yeah. Anyway,
I'm registered in Maryland.
So,
I live in Colorado.
if you look at this, right, this definitely satisfies that, and of course, if you plug in 0, it's going to give you back. If you plug in y equal to 0, you're going to get back what? You're going to get back.
You said plug in y equal to 0?
If I plug in y equal to 0, I get back 7b. Alright, so apparently I need to divide by b, which was part of the solution I had earlier. I somehow lost track of that. Right? Isn't that what I said to do? Yeah.
Oh,
Yeah.
A sub naught,
over b.
I have to do a sub naught tilde over, I have to divide by b. I forgot about that. I said we had to do it earlier, but I didn't actually do it. Not doing it, checking my answer, I see I'm missing it because if I plug in y equal to 0, this gives me 7b over b, which is 7. But without that division by b, I don't get back the 7 that I need. Over here, plugging in y equal to 0, I get what? I get sinh 3b. There's a minus there. Sorry about that. And so then they cancel and leaves you cosine 3x. You get 7 plus cosine 3x.
Right.
So a lot of moving parts here. It's a little bit more forgiving than integration in the sense that it is possible to get a solution, as we've just been seeing, about 90% right, but to have about 10-20% of just the details off. And checking the answer at the end will help you find those things, right? Like I'm showing you right now. If we just plug in the data, we can kind of hunt down where we forgot to make good on things we promised to do 30 minutes ago in the calculation. And then these guys, 1 and 2, are automatically satisfied because of the things that we've done in the last hour. But there you go. That is a solution. That will give that describes the voltage in a rectangle where you've put a cosine voltage down here, shifted up 7. 0 electric fields, and then grounded at the top. That would be the voltage distribution. We follow this formula in there, and he has a graph of what that looks like for some particular example. Here, this is not. It's kind of a sad example. Well, it's not sad. It's better than what I have, which is done. But this is for f of x equals to this particular function, like x and pi minus x. It's like a part of a sawtooth, I suppose. So I don't know. You can't see much from that. But
Not
anyway,
really. Yeah, it's not clear.
yeah, it's okay.
I bet he used mathematics.
Anyway, that's how you solve Laplace's equation on a rectangle, roughly speaking. I mean, yeah, it's a lot of calculation, but it's calculation you can do, right? And all you got to do is these Fourier integrals, and you can pretty much figure out what the voltage function is on such a plate. How are we going? And this can be modified, right? Like you can play games where these are fixed, like you ground both sides, and you do other. I mean, there's other versions of this that the same general solution technique will solve. But well, now you have seen a full-fledged example of all of 3 of the major PDEs. As you can see, it takes me a while to do these examples, and we've just done examples, right? We haven't done theory or anything yet. But these are the examples, and I think it's important to see the examples first, actually, because it brings the theory to life more.
Gave up on going back and putting the
Thanks, guys.
negatives and tildes in.